In our last video, we talked about basic geometry vocabulary, points, lines, planes, segments, and rays. There's going to be more vocabulary coming at you from this video, all about angles. I apologize, it's so much vocabulary to start the year off, but it's important that we know what all of these words are and the proper notation so that we can use them all year long in geometry. So make sure you have a pencil and notebook ready to go, taking notes throughout the video, pause the video when you need to, write down questions and bring them to class next time. Angles are created with two rays that have a common endpoint. That common endpoint is called the vertex. If you remember from our last video, we talked about opposite rays, and those were rays that shared a common endpoint. So that's actually a type of an angle. It's just a special type of an angle because they go in opposite directions. And we'll talk about that in just a little bit, but just to connect to our last video a little bit, we have a ray and another ray that they share that common endpoint called the vertex. And this is the angle that we would refer to. Hopefully some of this vocabulary coming up is familiar to you. Acute, right, obtuse, and straight are all types of angles based on their measurements. An acute angle is less than 90 degrees. So that might look something like this. A right angle is exactly 90 degrees. Right angles have this little box in the next to the vertex. That symbol will always mean there is a right angle there. So if you're given that, you automatically know there's a right angle. Obtuse angle is greater than 90 degrees. Might look something like this. And then finally we have a straight angle, which, just like you would think, it's completely straight. It makes a line, and that's 180 degrees. So this is what we get when we have those opposite rays. Two opposite rays creating this line, 180 degree angle. Next, we'll talk about how to measure angles. We will practice this a lot in class next time with protractors. But we're going to talk about how you measure them with a protractor, so hopefully we can jump right into it in class. So with protractors, there's either like a hole or some kind of a dot down in the bottom middle. That is where you want to put your vertex. Then, notice on both of these, there's a ray lined up at 0. So it's really important when you have an angle that you put the vertex in that circle, open circle, or that dot in the middle, and you line up one of the rays, one of the sides, at 0. That might mean, depending on how it's drawn on your paper, that you have to turn the protractor and slide it around to get it in the right position. Also notice how these angles, this one, the side that is touching 0 is on the left, and the other one is on the right. So it does not matter, and that's why we have numbers on the top and bottom, depending on which direction we are looking at the angle coming from. So this one on the left, we see that it's starting on the left and it's going up. And here I see 50 and I see 130. And then we ask ourselves, well, what makes sense? I look at this angle and I can tell by looking at it that it's an acute angle. It looks small. So that means it cannot be 130. Acute is less than 90. It has to be 50 degrees. And if I look here, it starts at 0, going this direction. I see it's going up from 0, it only gets to 50. If I look here, 180 going down doesn't make sense. We're starting from 0 every single time. So this is an acute angle. It is 50 degrees. When I look at the next one, this time it's starting from the right at 0. So if I go here, it's a little bit more detailed. I don't know how well you can see this, but it's either at 53 or it's at 127. So I look at this angle and I see, okay, it started from 0 here, and it's going this way. It's definitely more than 90. It's definitely an obtuse angle. So 53 doesn't make any sense. 127 degrees, this is an obtuse angle. One other thing that is a common mistake is when I look here, I notice this is between 120 and 130, so that's how I knew that this was 127. Sometimes people look at this kind of from both directions and think, oh, it's 53, so it must also be 133. And that's not the case. It's 127. So make sure that you're looking from the right to the left for this one. It's less than 130, so it can't be 133. That's a common mistake. Next, we'll talk about how to name an angle. So in our last video, we had special symbols that we used to name a line and a segment and a ray. Same thing here. So I have an angle. We use just a little angle symbol before I name it. So again, with lines, we needed 2 points to name a line, a ray, and a segment. With an angle, we need 3. So we can see this A, B, and C. We say angle A, B, C. I could also say angle C, B, A. Now, with angles, it's really important that the vertex is in the middle. If I would say, if I would say angle CAB, then I would be talking about a completely different angle up here. So we need to make sure that we use angle B, or angle ABC, or angle CBA, using B, which is the vertex, in the middle, and 1 point from each of the rays. It doesn't matter the direction as long as vertex is in the middle. The other way that we can name an angle is by just using the vertex. We could say this is angle B, and that's a lot shorter and more simple to say. So that's another option for us sometimes. Okay, I'll show you another example of why we can't always do that. Finally, the last way that we can name an angle, sometimes there will be a little number in there, so we could say that this is angle 1. A lot of times it depends on what you're given, and that's how you determine how to name the angle. So our next example, I see there's actually 3 rays involved, which creates more angles than just one. I have this angle, I have this angle, and I have this larger angle. So I actually have 3 angles here. If I wanted to name this angle, I could say angle A, B, D, or I could say angle D, B, A. Okay, thinking of our last example, I could use angle B. But if I say angle B for this one, I don't know which angle we're talking about because all 3 angles use B as their vertex. So when that vertex is used for more than one angle, we cannot name the angle just using the vertex. We need to be more specific to say angle ABD, or I could be talking about this angle and say that this is angle CBD. But if I just say angle B, we don't know which angle we're talking about. So we have to be careful. We can only use that if there's no other angles using that vertex. Okay, then let's look at this big one. We could call that angle ABC. Notice all of them have B in the middle because B is the vertex for all three of those angles. Few more vocabulary words to throw at you. We have adjacent angles. Adjacent angles are sharing a side. A side is one of the rays. It shares one of the rays. So if I look at this angle 1 and angle 2, they share this ray in the middle. So those are adjacent. They're next to each other. If you want to think about that, next to. Okay. Then we have vertical angles. Vertical angles are created with two intersecting lines and they are opposite of each other. Sorry about my writing on this one. So angle 1 and angle 2 are vertical angles. They are opposite of each other with these two intersecting lines. This angle here and this angle here are also vertical angles because they are opposite of each other with these intersecting lines. Congruent angles, so hopefully you remember congruent from the last video, meaning exactly the same. So these angles are the exact same size. They're both 48 degrees, I think it says really tiny. These angles are congruent. Same measurement. Remember, we use our congruent symbol. This would be angle A is congruent to angle B. I'm sure you can't see those letters, but this vertex is A and this vertex is B. Angle A is congruent to angle B. Just like we had those congruency statements with segments, we can do them with angles as well. Then we have complementary and supplementary angles. Complementary, they add to 90 degrees. So I see these two smaller angles added together create that 90-degree angle. I see two examples here, the 50 plus the 40. They don't have to actually be touching each other to be complementary. They add up to 90. And in the second example, they are adjacent angles. Thinking of that other word we talked about, adjacent angles that are complementary as well. Supplementary, they add up to 180. Same kind of idea there. It shows you two different examples of them touching each other, being adjacent, or just separate angles that add up to 180. Finally, we have a linear pair. It's kind of just what you would think. It's a pair of angles that create a line. We can also think about that they are supplementary, because a line is 180 degrees. So linear pair is always supplementary. Supplementary usually is a linear pair. If we see this example here where they're not connected, it's not a linear pair. But the second one is. One quick thing I wanted to add before I forget. You might have noticed when I talked about congruent angles, this is a better picture of the one from the previous slide. I did this to show that they were congruent. So when we had segments, we had that little hash mark to show that they were congruent, right? So with angles, we see this little arc that shows these angles are congruent. If I had another set of angles that were congruent, I might have two little arcs to show that those two are congruent. So just keep that in mind. It's very similar to the hash marks that we did with segments, but we use these little arcs with angles. Remember to bring your notes and questions to class next time.